Okay, I'd like to take a minute to talk to you about isomerism. And for isomerism, there are several different kinds. Structural, positional, functional, and last but not least, stereo. So what I need for you to do is to first of all understand what is the meaning of isomerism, and also be able to tell apart the different types of isomerism. So what I like to do is, first of all, to use structural isomerism to explain to you what exactly are isomers. So let's start with this molecule, CH4. Okay? You all learn what CH4 is. It's called methane. The structure looks something like this. Okay? It's just one carbon with 4 hydrogen. So if you ask, is there a different way to draw CH4? The answer is no, because it doesn't matter. How you look at the CH4 molecule is always going to be CH4, and there's only one way to look at CH4. And therefore there is no isomer. There is no isomer for CH4. Okay? Well, so CH4 is not an example of isomerism or structural isomerism. So what is a good example? So why don't we jump to C3H8, which is called propane. Okay, so I'm going to draw a structure for C3H8, and it looks exactly like this. I'm going to put the hydrogen just so that you know where they go. Okay, so that's C3H8. Is there another way to draw C3H8? The answer is still no. Okay, there's no other way to draw C3H8, because even if you draw it like this, or like this, okay, it's still the same molecule. So actually this is not a good example. What I meant to say is actually the next molecule in the alkane family, which is C4H10. Now you know what I'm getting at, right? When I said that propane does not have isomerism, or at least no structural isomerism. Well, this is C4H10, and this is called the butane molecule. Okay, but there's another way I can draw C4H10. And actually this molecule appeared before in class. I use it as one of the examples of something else. But it's also a good example of what we call structural, again right here, structural isomerism. So this is butane, where you see the 4 carbon joined together like this. This is actually not butane, this is a propane molecule. Well, why is it propane? Because the longest carbon chain has only 3 carbon. 1, 2, 3. They have to be connected. This carbon is not connected, and therefore it does not count as part of the chain. So what is this molecule? Well, this molecule is propane because of the 3 carbon. This is butane because of the 4 carbon. But this is not just propane, because if it was just propane, then it would be like this. This is propane. So having the formula C4H10, I gotta have 4 carbon. And so the 4th carbon goes here. And then the hydrogens. Okay? This is what we call methyl. It comes from methane, because methane, remember, look like this. Okay, if I erase one of the hydrogens, this is the bond which is going to go here. Okay, So instead of calling this by the same name as methane, I call this by the name of methyl, because it's like almost like a functional group, but it is not. So it's like a functional group, but it is actually not. It's not a functional group, it's simply called a branch. So it's more appropriately known as a branch. But what I'm trying to say is that based on this formula here, C4H10, there are two ways to draw the structure. And these two are actually totally different compounds. They are different compounds. Okay? If you measure the properties, the physical chemical properties of butane, it is going to be totally different from that of methylpropane. Therefore, these two are structural isomers because they totally have different structures, although they share the same chemical formula, which is C4H10. So in your homework, you're going to be asked to identify structural isomers. So let me give you another example. Now for simplicity, this time I'm not going to draw all the hydrogens. But this molecule comes from the formula C5H12. C5H12. If you put all the hydrogens in, there will be 12 of them. But for simplicity, I'm not going to put the hydrogen. So this is my C5H12. Okay, I'm going to draw another molecule that might look something like this. So if you ask, is this an isomer? Or I should say, are these two isomers? The answer is no, because I can easily redraw the structure to be like this, and those two would be simply identical molecules. So let me try something else. Try to be a little bit more creative. In fact, you can draw it any way you want. Are these two isomers? So isomers or not? The answer is no. These are the same molecule. Again, because I can straighten this so that they look exactly the same. What we are looking for is actually connectivity. If you put number 1 on this carbon, let me use a different color. If this is carbon number 1, this is number 2, number 3, number 4, and number 5. You see 1 and 2 are connected, 2 and 3, 3 and 4, 4 and 5, these are all connected. Same as here. 1, 2, 3, 4, 5. All these carbons are connected. Well, remember, I can draw C5H12 a little bit differently. So let me again be creative. So I'm going to draw it like this. Are these two isomers? Well, the answer is again no, because this is carbon number 1, number 2, number 3. Okay, identical carbons. Well, 3 is connected to 4. So it doesn't matter how you draw it. The connectivity is identical. So these two, again, they are not isomers. Not isomers. Okay, so can I draw a structural isomer of this molecule here, which is called pentane? This is pentane. Okay, well, let's try something. So let's say I'm going to have 4 carbons connected just as the C5H12 pentane molecule. But this time I'm going to put a carbon here. Remember, this is called a methyl branch, or simply methyl. This is butane. So now I have a different molecule. It's called methyl butane. These two are totally different compounds. Here's carbon 1, 2, 3, 4. See, the 5th carbon is actually not connected to carbon number 4. You see the 5th carbon is connected to carbon number 4. Again, I can draw it like this. Doesn't matter. 5 is still connected to 4. But clearly here, 5 is not connected to 4. And therefore, these two are structural isomers. Okay? Now, can I draw another structural isomer? Let me put this one back to the original picture. Well, I can try to draw another one with 4 carbon, and let's say put this carbon over here. You might say, well, this and these are all isomers. Well, the answer is no, because this one and this one are the same molecule. You see, you can pick up a molecule, flip it over, and overlap the molecules. In fact, if you have trouble seeing this, what you should do is to take out your molecular modeling kits. This one right here, which you should all have, and try to build a molecule. Okay, well actually I'm not going to build it, but you get the idea. Okay, you can actually model this molecule, okay, and try to build this one too. And then once you have built both molecules, pick them up and rotate them until you see that they are actually identical molecules. So this is not an isomer, this is a trick. These two are the exact same molecules. Okay, they're both methylbutane. They're exactly the same. So let me try to draw you an isomer of C5H12, which is different from this one or this one. This time I'm only gonna have 3 carbon. I'm not gonna connect number 4 to number 3. I'm gonna connect number 4 to number 2. Now, how do you put the 5th carbon? Well, if you put it here, that's not going to be a different isomer. Put it here? No, still the same. So I'm going to put it over here. And now you see, this one is a propane because the longest carbon chain, here there are 4 carbon, 5 carbon. This one, there are only 3 carbons. So it's actually a propane. But there are 2 methyl groups, therefore we call this by the name of dimethylpropane. And these 3 are all isomers of C5H12. And these are all structural isomers because they are totally different structures. Based on connectivity, they are totally different structures. And this one has carbon number 1, number 2, number 3. Number 4 is over here connected to number 2, and carbon number 5 is also connected to number 2. So you can actually put this as 2,2 dimethylpropane, but you know, because there's not going to be another way to draw dimethylpropane, you can just leave it as dimethylpropane. Okay, so now you have an idea. What are isomers? These are isomers of C5H12, but they are, each of these, they are different compounds. They have different physical and chemical properties. So their melting point, boiling points are different, and their chemical reactions are also going to be different. And you can see that by also the names. Well, the structure is one thing. Of course, you can tell apart the 3 isomers by their structures. But of course, the name also implied that these are totally different molecules. So I just show you one way of looking at structural isomers. And of course, you can build the structural isomers yourself, other than to recognize what are structural isomers. So let me give you an exercise. Actually, this one is pretty difficult. C7H16. Okay, so I'm gonna start you off by drawing the straight chain. This is actually something called heptane. HEP stands for 7, HEPT, ANE. ANE stands for alkane. HEPT stands for 7. So there are 7 carbon in an alkane, so it's called a heptane. So I've got 7 carbon connected together. Again, don't fool yourself by drawing your molecule like this or like this. This is